So in this video I will show you how to draw projections of points. I'll be as precise as possible to reduce video length, and also this is a crudely recorded video, so kindly bear with me. This is just an effort to pass on information without consuming classroom interaction time, but nevertheless this is a very important section because it forms basis of all the further the series that we are going to learn. Okay, so we'll begin with projections of point. Okay, so let us see. This is a regular reference planes. This is VP and HP. This is XY line. Okay, now as you know, these two planes divide space in 4 quadrants. Now a point in 3D space, it could be located in any one of the 4 quadrants. So there are some standard terms that are used to describe location of point. For example, let us take point number A. So while denoting a point in 3D space, the actual point I'm using capital letter deliberately just to demarcate the difference clearly. And this point A, when projected on front view, it gives point A dash. So A dash is front view of point capital A, and A is top view of capital A. So A dash and A both form projections of point A. So when to describe location of point A, there are some standard terms that are used. So we'll just go through them. So I describe point A. One thing I can say, this is in first quadrant, but in other words, other way to say, point A is above HP, some distance above HP, and in front of VP. Okay, so if there is any point in second quadrant, say point B, I say point B is some distance above HP and some distance behind VP. If there is some third point C, I say point C is some distance below HP, some distance behind VP. And also if I have point D, I say point D is below HP, in front of VP. So this below and above HP and in front and behind VP. So these are the combination of, with this combination of these four terms, we describe unique position of these points. Now let us see them one by one. So this point A is projections of point A is A dash and A. Now let me give some dimensions. Say this is 50 mm and this is 70 mm. Okay, so this is point A is 70 mm above HP, 50 mm in front of VP. Also, so now to draw projections of point A. So if I rotate HP like this is the standard convention, the way we. Okay, so this is XY line, VP, HP. So projections of point A. So A dash, do you agree with me if I say, because this is 70 units, A dash will also be 70 up above the XY line, because this is 70, this is also going to be 70. So I draw point A dash, I plot at a distance of 70. Okay, so this is point A dash and the projection line, and this is point A. Because HP goes down, this entire distance, it will go down. So because this distance is 50, this is also going to be 50, which will come down. So this distance will be also 50. So these A dash and A, they are projections of actual point A. So this is about when a point is in first quadrant. Now when I say this point B, this is in second quadrant now. Its front view is say B dash, in top view is B. Now this is also a standard convention. Generally points in 3D space we denote with capital letters. Its front views we denote with the small letter and with a prime, with a dash above, prime, for front view. And for top view we just denote the point or the entity by its small letter. So again I gave some numbers, say this is 40 and this is 80. So how do I draw projections of point B? So I'll just make it here, if you can see this. So this is XY line. Now as you very well know that in case of second quadrant, the when you rotate HP like this part of HP and this part of VP, they overlap, and actually we never use a method like this, but still I will show you how this will overlap. Now this B is, because this is 40, this B is also going to be 40, this distance is also going to be 40, so this 40 is going to come up. I can plot both VP and HP will be here because they are overlapping. So I plot point B at a distance of 40. Then there is B dash point, which is again on this projection line, but this projection line will be here itself, nothing down, because they are overlapping above XY line. So B dash is, because this is 80, B dash is also going to be 80 mm above. So this is point B dash, which is also 80 mm above. So these two are projections, B dash and B are projections of the actual point B. Okay, so let us now talk about point C. Let this be C dash, let this be point C, small c, this is the actual capital C, and this is C dash. So if I say this is, say, 100 and this is 30. Okay, so how do I draw projections of point C? This is, well, I'll just make a boundary to help you understand. Okay. So I was talking to you about point C now. So point C, this is the reference line, and uh, now this is in third angle. This is third angle method. So HP is going to go up. This is HP, which is going to go up, and this is VP, which will remain here itself. So what you have above XY line is actually HP. What you have below XY line is VP. If you remember, in our first lecture of orthographic, we had seen this particular method of third angle projection. So when this HP will go up, this is 100 mm distance. So this distance is also going to be 100 mm, because this is a rectangle. So this is 100. This 100 distance mm distance is going to go up. So point C will be up. So I draw point C on HP, which is, this distance is 100. Okay, and then on its projection there is point C dash. So because this is 30 now, this distance is also 30. Now this, anyway, of course this is not looking proportionate, but this is 30 anyway. Let's take for the sake of taking the figure. So this is also 30. So point C dash, somewhere close, this is point C dash. So this is 30. Okay, so this C and C dash, they put together, they form projections of point C here. So this is as per third angle method, because point C is in third quadrant. Now let us see point D. So to avoid complication, I take it here. Okay, so I project point D on VP. This is D dash, front view of point D. This is top view of point D. Again, in fourth quadrant, HP rotate like this, so VP and HP, they overlap below XY line. In second quadrant, they overlap above XY line. Here they overlap below XY line. So what you obtain here actually is like this. This is XY line, and both VP and HP are below XY line. They meet each other. They overlap each other here. Well, so this is point D. uh, D and D dash, they are projections. So if I take some numbers to this, say this is 50, this is 70. Okay, so now you can very well understand, if this is 50, this distance is also going to be 50. If this is 70, this distance will also be 70, because this is a rectangle. Now this point D will come down, which is 50. So I plot point D at a distance of 50. and D dash point is here itself because it's on VP. VP is right here, and this point D dash is 70 mm below. Okay, so the same projection line on 70 mm below, I draw point D dash, and this distance is 70. Okay, so these are projections of points when they are placed in one of the four quadrants. So in this video I will show you how to draw projections of points.